So in this video, we'll be looking at software development models, right? The software development lifecycle model shows the way to navigate through complex and demanding process of software building, right? So a software project's timeframes, budget, ability to meet stakeholders' expectations, and quality largely depend on, the chosen model. Right? Today, there are more than 30 recognized SDLC models in use, right? None of them is perfect. They all have their pros and cons, and uh, each of them have, distinct, pros and cons that can play out throughout the life cycle of the project. But we're going to be looking at some of the most popular models in this video, right? So there are sequential evolutionary models, formal and informal models, right? There are lots of types of models, right? But we'll be looking at some of the most popular SDLC models in this video. So starting with the waterfall model, right? Starting with the waterfall model. So throughout all the development stages, analysis, design, coding, and testing and deployment, the process moves in a cascaded mode. Cascaded mode, that means each state has concrete deliverables that must be strictly documented, right? And these deliverables must come one after the other, right? So the next stage cannot start before the previous one is fully completed. So goes in a waterfall or cascades down. First, from requirement analysis to design to implementation to testing to deployment and then maintenance. All this must be followed sequentially in that order. So that's it for the waterfall model. So there are pros and cons to this waterfall model, but we won't delve into that here. So the next one we'll be looking at is the V model, verification and validation model, right? Verification and validation model, right? It's a linear model with each stage having a corresponding testing activity. Such workflow organization implies exceptional quality control, but at the same time, it makes the V model one of the most expensive and time-consuming models, right? So even though there can be mistakes in requirement specification code and architecture errors can be detected early, right? So changes during the development is still quite expensive and difficult to implement. As in the waterfall case, all the requirements are gathered at the start and cannot be changed in the V model, right? So that's the V model. So for each phase, it has a testing activity attached to each phase of the SDLC using the V model. There's also the incremental model, right? The incremental model is split into several iterations, right? Lego style modular software design. New software models are added in each iteration with little or no change in earlier added models, right? So development process can go sequentially or in parallel. So that's for the incremental model. Now, the next model we're looking at is the iterative model. The iterative model of software development. Right, with iterative model of software development, software changes on each iteration, evolves and grows. As each iteration builds on the previous one, software design remains consistent. So as the software is delivered in parts, there's no need for the full specification though of the project. Small changes and requirements are possible in the course of the development process, right? That's for the iterative model. But you can't really change stuff radically, or it will break the process or it will cause major issues in the process. So there's also the spiral model. We'll be looking at the spiral model next. The spiral model puts focus on thorough risk assessment. So to reap benefits of the spiral model, you need to have people who are specialized in risk assessment, right? Typical spiral iteration lasts 6 months. I'll start with, of course, 4 important activities, including thorough planning, risk analysis, prototype creation, and evaluation of the previously delivered part. So repeated spiral cycles can extend project timeframes. So we also have the rational unified process, right? Rational unified process is basically a combination of linear and iterative frameworks, right? The model divides software development process into 4 phases, which are inception, elaboration, construction, and transition. Okay, so each phase, but the inception is usually done in several iterations, right? All the basic activities, including requirements, design, and etc. of the development process are done in parallel across the 4 RUP stages. So that's it for rational unified process. Then we come to the agile group, which a lot of companies use today, right? I have a lot of experience in the agile model, right? And using Scrum, and I still use that, on a day-to-day in my software development and QA activities. So let's look at Scrum next. Scrum, probably like the most popular agile model. Scrum is done in sprints. The work is done in sprints, and a sprint can typically last up around 2 weeks, right? 2 weeks to 4 weeks, right? So they are preceded by, of course, thorough planning and previous sprint assessments, right? No changes are allowed after the sprint activities have been defined, right? So that's the Scrum model: plan, design, develop, test, deploy, and review in sprints. All these activities happen in a sprint, which can span between 2 to 4 weeks. And of course, start all over again in the next sprint. So there's also an extreme programming model. The next model we'll look at is extreme programming. Of course, in the extreme programming model, it typically lasts between 1 to 2 weeks. It allows changes to be introduced even after iterations launch, and if the team hasn't started work with the relevant software piece yet. Such flexibility significantly complicates the delivery of quality software, right? XP uses pair programming and test-driven development and test automation, right? Test automation, continuous integration, CI, and small releases and simple software design as prescribed to follow the coding standards, right? So the extreme programming, they release software in small releases, and using a lot of test automation and CI/CD to ensure that these small releases are working up to date, and there are fewer issues associated with these releases. So that's it for extreme programming. And the last one we're looking at is Kanban. Kanban. So they are extremely short daily sprints. So instead of emphasis being placed on plan visualization, so the team uses a Kanban board, right? A Kanban board is just like it's a board that can be used to track tasks, right? Provides a clear representation of all the project activities, their number, responsible people, and the progress, right? Such increased transparency can help to estimate the most urgent tasks more accurately. Also, the model has no separate planning stage, so a new change request can be introduced at any time. Communication with the customer is ongoing, and they can check work results whenever they like. And the meetings with the project team can eventually can happen even daily, right? So this model is used a lot in software support and evolution when they are supporting software, where software support is being carried out right? This model, Kanban model is the most popular model for software support because of increased transparency and quick deliverables, right? So, like I said, there are many other SDLC models, but we'll be going into all of them. Can't cover all of them in the video, but I've covered some of the most popular and interesting SDLC models. You can also do some research and look up other SDLC models online, and I'm sure you'll be able to benefit from such activity. So that's it for software development models, and I'll see you in the next video.